All right, so this is our last lesson for the unit. That means after this, which is Monday coming, you'll have the last quiz on what we learned in 1.3 and 1.2. And the test is going to be on Tuesday. So Monday, you come in, you do a little bit of your review, okay? So you can finish your homework, your review in the homework or whatever. And then after that, you can do the quiz. We'll do the quiz around maybe 9:30, okay, just to give time for people to come in and do their quiz. And then you can continue on working on your review. And Tuesday you'll have the test, okay? So we learned yesterday something very important. We learned that sine, cosine, and tan can have same answers for different angles, but their sign changes depending on what kind of angle I have. What did we learn about sine ratio? They're always positive for both acute and obtuse angles, right? What did we learn about cosine? Positive for the acute, yep. Negative for the obtuse. How about the tan? Same. So same as the cosine, right? And we learned the word supplementary angles, and what does supplementary angles mean? So they add up to 180. Good. So we're going to look at why is this? Why this happens? Why sine for obtuse is positive, cosine for obtuse is negative, or tan is negative? Why? Okay, so this is the reason behind it, and then we're going to talk about this in more detail. So an acute angle is an angle that's less than 90. An obtuse angle is between 90 and 180. And then we learned that supplementary angles are two angles whose sum is 180 degrees. So everything goes back to the Cartesian plane. So the Cartesian plane is the x and y plane that we know, okay? So if you look at the x and y plane, it's cut into 4 quadrants, right? You have quadrant 1, 2, 3, and 4. Quadrant 1 is the positive quadrant, okay? Why we call it the positive quadrant? X and y are both here, positive. Yes? All right. Now, quadrant number 2, which one is positive and which one is negative? So the x is negative, right? So if you look, your x is negative, but your y is positive. Are we okay with this? Now, I'm going to just talk quickly about quadrant 3 and quadrant 4. We don't cover quadrant 3 and quadrant 4 in this course. This is covered in the U-level courses, okay? But if you look at the quadrant 3, x is negative and y is negative. And then quadrant 4, we have y is negative and x is positive. But as I said, we only cover the first 2 quadrants here, okay? So let's look at our angles. So when I measure my angles, there is always a rule that you measure your angle from the positive x-axis, okay? So if I'm going to draw, if I have my quadrants, okay, and I'm going to draw a line like this, to measure my angle, the angle measures from the x-axis all the way to what we call the terminal arm. Okay, so this is my angle. So to measure your angle theta, you measure it always from the positive x-axis. Do we understand that? To the terminal arm. I'm going to show you more examples, so don't worry about this. But I just want to define few words. Okay? Now, if I have an angle in the second quadrant right here, okay? This is where my line is. How do I measure my angle? Angles always measured from the positive x-axis. So it's going to go from here all the way to the terminal arms. What can you tell me about that blue angle? It's an obtuse angle. What can you tell me about the red angle? It's an acute angle. Why is the red angle an acute angle? Less than 90, right? So if I'm looking at my measurements of the angles, this is angle 0, right? Because technically speaking, if I have an angle that's lying on the x-axis and I'm measuring this angle, what's my angle? 0. There's no angle, right? Now, if I'm looking at my y-axis, what is that angle right here between the x and the y? What is that angle? 90. Okay? So anything between the x and the y, anything in the first quadrant, is going to be between 0 and 90 degrees. Right? So if I'm telling you, where's angle 60? It's in the first quadrant. Right? So angle 60 is going to be, if you're going to draw angle 60, it's going to be somewhere right here because that's angle 60. Right? If I say angle 30, right? Same thing. It's going to be in the same quadrant, but it's going to be closer right here, and that's angle 30. Okay? So any angle that I give you between 0 and 90 is going to go in the first quadrant. Do we understand that? All right. Now, then what would we measure that negative x-axis? What would that measure? What would that angle be at the negative x-axis?
0.
So if I go, remember I always measure from the 0, from the x-axis, sorry, right? So if I go from here to here, what's my measure? 180. So now I know my 3 important angles. The 0 angle, the 90 angle, and the 180 angle. Okay? So if I give you an angle that's 120, where would you locate that? Quadrant 2, right? It's quadrant 2 because 120 is between 90 and 180, right? So now we know that in quadrant 1, we have all the acute angles. So any acute angle between 0 and 90 is going to be located in the first quadrant. Any angle that is obtuse is going to be located in the second quadrant. And we understand that we always measure our angle from the positive x-axis to the terminal arm. Are we all good with that?
Yes.
Good. So, using the origin as one of the angles, any triangle can be defined within the first 2 quadrants since any angle in an oblique triangle must be less than 180. Okay? We know that because the sum of all the triangles is 180. So any angle inside of a triangle has to be less than 180. Right? Otherwise there is no triangle. Right? So let's look at what happens to my triangles and how can I draw them, and what happens to my SOHCAHTOA depending on where my point is. So, if I have a point, xy, and is in quadrant 1, then we know that angle A is an acute angle. Let's look at that. So give me a value for xy. Give me a point in the first quadrant that I can fit here. Let's use 3 and 4. Okay, so let's use point 3, comma 4. Okay, so instead of using x and y, I'm going to use points because then it's clear for you how does that work. Okay, so if I look at point 3, 4, this is where 3 is. 1, 2, 3, 4. This is where 4 is. So my point is right here. Are we okay with the location of the point? Okay. So now if I want to draw a triangle, right? If I want to draw a triangle, you're going to draw the triangle from the origin. Okay? So your terminal arm has to be going from the origin to the point. So it's a straight line from the origin to the point. So this is my terminal arm. Okay? Are we okay with this part? All right. Now, to complete the triangle, so this is point 3, 4. To complete this triangle, you're going to draw a vertical line always going down to the x-axis. Okay? So if you see, if I draw a vertical line here, going from the point down to the x-axis, do you see now my triangle? So I have a triangle here. 1. This. That forms a triangle. Okay? Now my question to you is, can you make the triangle this way? No. The answer is no. The triangle has to go down and make an angle with the x-axis. Because remember, the measure of my angle has to be from the x-axis to the terminal arm. So I have to have this angle right here. I can't have that triangle outside. Okay? So always you're going to have to draw your line going down to the positive x-axis or to the x-axis. Okay? So let's look at this triangle. What kind of triangle is this? Right angle. With a right angle, with an angle right here. Okay? I'm just going to erase that highlight. Okay? So I have a right angle triangle. And where's my angle of interest? Which one? At the origin. So this is my angle of interest, because remember that the angle of interest is always measured from the positive x-axis. So this is my angle of interest.
Sorry, so the angle of interest is always measured from where?
It's always measured from the x-axis. Do we know if this angle is an acute or obtuse? Yes. What is it? Acute. Now, according to this triangle, I'm just going to draw this triangle out here just because I like to have a clear view of it. Okay, so this is the same triangle that you have in your x and y quadrant. Okay, and this is your theta. Oops. Okay. Now, according to this angle theta, where's your opposite, where's your adjacent, where's your hypotenuse? This is your opposite. This is horizontal, so that's the adjacent, yeah. And that's your hypotenuse. Okay? Okay, so if I'm looking back at this triangle here, this is your y value, isn't it? This right here, that's your y. And what is this? X. And this is hypotenuse. It's the radius of your circle. Okay? If I'm actually going to draw a circle here, that's your radius. Okay? So if I'm going to compare opposite and adjacent with y and x, opposite is what? 4, which is what letter? Y or x? Y. So opposite is your y, and the adjacent is your x. Now the hypotenuse, I don't know it. I have to find it. How can I find my hypotenuse? Do I have enough information to do so, Katoa? Yeah. Do I have my angle? I don't have my angle. I can't use SOHCAHTOA. Pythagorean theorem, because I have two sides and I'm looking for the third one. Okay, so I know this is 4. I know this is 3. I can use Pythagorean theorem to find my radius or my hypotenuse. Okay, we're going to call the hypotenuse R because, as I said, if I actually use the origin here and then I can draw a circle with this radius. Okay, so that's why we call it R. Okay, so the first thing that I can do here is I'm just going to write the values here. So this is 4, this is 3. Okay? So you see how we're using our old knowledge, which is the opposite and adjacent and hypotenuse, but we're calling them something different right now. We're calling them Y and X and R. Okay? So we're doing still the same thing. We're still doing SOHCAHTOA, right? We're still using adjacent opposite, but we're calling them something different right now. We're relating them to a point. So, first of all, I'm going to find R, or the hypotenuse. What do I do to find R? X squared. Good. Right? Because R is C, or is the hypotenuse, right? Which we used to call C. C squared equals to A squared plus B squared. My A is X. My B is Y, or vice versa. Let's plug in the values. So R squared equal, what's X? So that's 3 squared plus 4 squared. So that's 9 plus 16, which is 25. That means R is 5. So taking the square root. Are we all okay how we found the radius? All right. Now, we're going to use the trig ratios, so sine, cosine, and tan, but we're going to find them with X and Y and R, okay? So sine is what? What's sine? In SOHCAHTOA, sine is what? What do I call the opposite here? What do I call it? What letter? Y. Over. What's the hypotenuse? R. Okay? If I want to find the value of it, I can say that it's 4 over 5. Okay? So instead of using the old-fashioned opposite over hypotenuse, we're going to use now Y over R. What's cosine? So X is adjacent over. What's my adjacent? What letter does my adjacent represent? X over R. What's the value of X? 3 over 5. Anyone doesn't understand where I'm getting all these letters and numbers from? Okay? Now can you find tan? So tan is opposite over adjacent, TOA. What's the opposite? What letter? Y over, which is 4 over 3. Okay? So you see these new letters, right? These new formulas, right? They come from SOHCAHTOA, right? But we're using XY because if I have a point, I know what X is, I know what Y is. Do you need to memorize them? No. Do you need to know them? Yes, right? Can you find them by using the known SOHCAHTOA? Yes, you can, right? Do I know them by heart? Do I memorize them? I mean, because I've used them a lot, I do know them, right? I know that it's Y over R. I know that it's X over R. I know that it's Y over X. But can you do exactly what I just did to get to the formulas? Yes, you can. It takes you a little bit more time, right? Now, can I find my angle using any of the ratios? Yes. All what I have to do is pick one, sine, cosine, or tan, and do the inverse. Okay? So I can pick whichever one. They all have to give me the same answer, right? Hopefully. So if I do sine inverse to find the angle, sine inverse of 4 over 5. Can you do that on the calculator for me? 53 degrees. Okay? And then I should get exactly the same answer if I do cos inverse of 3 over 5. Right? It's 53. Do I need to use all of them? No, I don't. Pick one and use it. Okay? Even if you do tan inverse of 4 over 5, 4 over 3, you should be able to get the same answer. Okay? So what did we notice about the sine, cosine, and tan here? What's their value? Positive or negative? All of them? Okay. Any questions about this particular example? So we learned to locate the point, draw a line from the origin to the point. That would call that the terminal arm. Then make sure that your triangle is a triangle with the x-axis. Okay? Are we? No, you cannot. You have to draw your triangle with a line going down to the x-axis. So you have to have this line going down to the x-axis. You cannot draw your triangle. So if you have this, right, you cannot draw this triangle. This is not right. Okay? It's equal to 53, yep. Okay, now we're going to look at a similar example, but this example is going to be, the point is not going to be in quadrant 1. Okay, we're going to look at what happens if my point is in quadrant 2. Okay? All right. So give me a point in quadrant 2. Same values, 3 and 4, but what would change? Which one is negative? The x is negative, right? So if I'm going to use the point, it's going to be a point which is negative 3, 4. Okay? That's in quadrant 2. So if I'm going to draw this, okay? So this is my point, which is negative 3, 4. I draw a line between the point and, first, where do I draw my line, my terminal arm? From where? From the point to where? To the origin, guys, to the origin. Okay? So you have to draw a line from the point to the origin. Okay? And then to form my triangle, I draw a line, vertical line straight down, okay, which form my triangle right here. Now you see that triangle. If I'm asking you for your angle, which is your not the angle of interest, it's more I'm looking at the primary angle, okay? Your angle that you're looking for. Where's your angle that you're measuring or you're looking for? Where do we measure our angle from? from the positive x all the way to the terminal arm. Okay? So technically, this is my angle that I'm looking for. Okay? Let's call that angle A. Is angle A obtuse or acute? Obtuse. It's in the second quadrant. You see how it's bigger than 90? Right? It's greater than 90. But this angle is not inside my triangle, is it? No, it's outside my triangle. But what do we know about this angle A? And then if I look at this angle here, what do we know about these two when I add them together? What do they give me? 180, which means they are supplementary angles. Okay. So, what do we call this angle? Let's call it theta. This is my angle of interest at the moment. Okay?
Which one?
That theta. Because if I'm looking at the triangle, right? This is the angle of interest. Where's my opposite? The vertical line, and that's what letter? X or Y? It's Y, because it's the Y value, right? Vertical is Y. And then where is adjacent? The bottom line, so the horizontal line, and that's the value of X. And then my hypotenuse is this, and we call it letter R. So same idea. I know what my opposite is. I know what my adjacent is. I just don't know what my R is, or my hypotenuse, right? So to find R, what do? Pythagorean theorem. So R squared plus equals, X squared plus Y squared. So if I put my values in, X is -3, and Y is 4. So that's going to be -3 squared is? I've heard different answers. Which one is it? +9, right? Because -3 squared is -3 times -3. How about 4 squared? So that gives me 25, and that means R equals 5. So if I'm looking for sine, remember that the angle, technically the one I'm measuring, is the big angle, right? Because I'm looking at my original angle. Now if I'm looking at sine A, so sine is what? Sine is what? What's the value of sine? What's the value of y? What's the value of r? What do we know about cosine? What's the value? What's the letter that represents for r? What's the value of x? What's the value of x? -3. What's the value of r? Stop right there and look. What's the value of cosine? What? What's the value of cosine? -3/5. So that's a -3 value. Do we know that? Did we expect that cosine to be negative? Yes, because my angle is an obtuse angle. Remember that. I'm looking at, this is the measurement of the angle that I'm looking for, right? This here is just my supplementary angle, okay? I'm just going to use it to form the angle, okay? But technically, the angle that I'm looking for is that angles are we expecting? Okay, what's the formula for tan? Opposite over adjacent. What's the letter that represents the opposite? And the letter that represents the adjacent? What's the value of y? The value of x. It ended up being negative. So it's not a coincidence that when you do on the calculator tan of 120 or tan of whatever angle that's above 90, that you're going to end up with a negative. There's a math behind it. And the math is because it falls in the second quadrant. And in the second quadrant, your adjacent or your x value is negative. Okay? Do we understand that? Now, after we do all of this, we found that perfect. Sine is positive, which we expected that because we know sine is positive in quadrant for obtuse and acute. We found out that cosine is negative and tan. Now the question is, how can I find my angle? Now here's the trick, and here's where you need to use your common sense, because it depends on what ratio you decide to use. You're going to have to change your answer accordingly. Okay? So here's what I want you to do. On the calculator, you decided that you want to use the sine ratio to find your angle. Okay? Do on the calculator sine inverse of, what is the 53? Is that the angle we are looking for? So if I put that in my calculator, which angle is it actually giving me? A, theta, or something else? It's giving you theta, right? Because the calculator doesn't know if you're in the first or second quadrant and you put sine in. The calculator is programmed that if you put a positive sign, it's going to give you a listen. No. Because I found this, now it's easy for me to you decided to use to give you the one in the second quadrant. Okay? Now, if you decided to use tan, because sometimes the question kind of forces you to use one of the three. Okay? If you were asked to use tan inverse, it gives a negative angle. What does that even mean? What does it mean when the calculator, you need to know your calculator. You need to understand your calculator, and you need to know what the calculator is giving you. Okay, so I'm going to just open a new page here because that's very important.